Hello. Welcome back to the channel. Today we'll be starting with a new series on the topic, Computational Fluid Dynamics, also known as CFD. Let us begin with some history. CFD was born during World War II, when scientists at Los Alamos National Laboratory were developing the atomic bomb and the numerical tools to describe the violent flow created by such a device. Among them was mathematician J. von Neumann, who contributed the keystone method of artificial viscosity for capturing shocks in numerical solutions, and is regarded as the father of CFD. So what is CFD? CFD is a simulation tool, used to predict what will happen, quantitatively when fluids flow, often with the complication of simultaneous flow of heat, mass transfer, phase change such as melting, freezing, boiling, chemical reaction like combustion, rusting, and mechanical movement of pistons, fans etc. CFD uses a computer to solve the relevant, science-based mathematical equation, using information about the circumstances in question. In simple terms, CFD methods allow the user virtual experiments that would be expensive, difficult, dangerous, or impossible in the real world. CFD modeling is governed by underlying fluid dynamic equations, mass, momentum, and energy conservation at the same time. CFD helps predict the fluid flow characteristics using software tools. Typical software involves 3 stages of CFD simulation. The first step involves building of the model, using appropriate meshing, and the boundary conditions, and information about the fluid properties. The next step is solving the various momentum, mass, and energy balance equations by discretization, and producing results of the analysis. Finally, the last step involves interpretation of data in the form of vectors and contour plots to find the necessary solution. CFD is applied to a wide range of research and engineering problems in many fields of study and industries. Well, I guess that was a lot for today. Stay tuned for part 2. Thank you for watching.